So my dear friends, I am Avigyan Tiwari working as an assistant professor at SIITS Bhopal. So in continuation of this deterministic finite automata, today we are going to see DFA, a quick revision of that deterministic finite automata and construction of DFA. So this is a very quick revision so that we are going to use, these are the pictorial representation that we are going to use to make a DFA, to construct a DFA. This is a notation for initial state, and that is what this is a quick revision. Okay, so this is a notation which we are going to use for final state, and this is for transition for a single input. This is a transition for two inputs, and this could be also happen if we'll have for input we are going to move towards the same state. Okay, so it will be a self loop. Okay, now let's take an example. So first of all, try to understand this question. Make a DFA that accepts all strings ending with 0, 1 over alphabet 0, 1. So sigma is given here. So we know the 5 tuples. So sigma is what? Input alphabet. Okay, so input is what? 0 and 1. So by taking this input, we are going to construct all the strings. The string for which we are going to make the machine, it will be constructed by using only 0 and 1. So string will be a combination of all the combination of 0 and 1. Okay, so ending with 0, 1. So what does it mean? If any string is ended by using 0 and 1, that string will be get accepted. So what will be the minimum length of a string? Is 0, 1. What is the minimum length of a string? Is 0, 1. And whatever with the combination, it can have infinite number of combination when we are going to create this string. So what will be the combination it can have? 0, 0, 1, 1, 0, 1, 1, 1, 0, 1. All these strings are going to be accepted because they are ended with what? 0, 1. They are ended with what? 0, 1. Good. Now let's try to understand. So there will be an infinite number of strings. Okay, so how we are going to make a DFA? So try to get the concept. Okay, so the minimum length of a string is what? 0 and 1. Okay, so for 0 and 1, we are going to make the transition diagram. So the first state is Q0, and this is initial state. And for 0, we will transit from Q0 to Q1. Okay, and for 1, we are going to transit from Q1 to QF. This will be final state. So this is for minimum length of string, and this is the notation for 2 circle. Okay, so this diagram is true for what? For this string 0, 1. But we can give any string. This is for all strings of 0, 1 if it is ended with 0, 1. So what will be the approach? Try to understand. I am not going to consider all the strings, all the infinite string. What I am going to consider, in each state, for each input, we are going to take the transition, and by taking care of this condition that it should ended with 0, 1. What I said, I am repeating it once again, that in each state, for each input, we'll have to take the transition. Okay, so let's do it. Okay, so in Q0, for 0, we can transit from Q0 to Q1. Again, we are left with only 1. So for 1, where we can move? Let's try to understand. Okay, for 1, I can move to Q1. Yes or no? I can move to QF for what? 1. For 1. These are the possibilities right now which I am showing to you, or I can move to here itself. So which one approach will be going to accepted? Either this one, or this one. Okay, so there will be only one move for a single kind of input. We know the meaning of this DFA. So which one will be going to be accepted? See, whenever I insert an input, we have 3 options: Q1, QF and Q0 itself. So if I'll take this one, what will happen? See, whenever I insert an input, by taking that input, we'll have to move towards final state, and we'll see what kind of string we reached through this final state. Okay, let's try to understand this. I have inserted right now this one. I'm considering this one. So for 1 I will move Q0 to Q1, and again for 1 I will have to move QF. So for 1 I will reach to the QF, which is not the condition. So it should not be true according to the language. Okay. So what I considered right now is not right. Again I'm going to consider this one, this way. Good. So what will happen here? So for 1 again I will reach to Q0 to Q1. So for single one it is going to be accepted. So again it is not the condition. So it will not going to be true. This will be cancelled. So we are left with only one path, that is this one. So now what to do? Again for this one, what we are going to see? See, this 1, 0 and 1. So what is 1, 0, 1? See, at last we have this 0, 1. So this will be accepted. So this will be the true. So if we have only 3 conditions, 2 conditions are false, then the left condition is going to be true, and it can be seen very easily here itself. It can be seen here very easily. So this will be the accepted. So this will be caused. So we are left with only one, this one. Okay. Now let's see. So let's try to understand what we did right now. So we'll have 3 options. So starting from very start. So from Q0 we will take for the input, that is what, 1. Okay, because in each state, in each input we'll have to take a transition. So in Q0 we are done with this 0, and that's why we are taking care of this 1 itself. Okay, so for one input we'll have 3 options to move. That is for Q1 we can move to QF, and we can move to Q0 itself. Okay, so we checked by when we checked for an input, we'll have to, by considering that input, we'll have to move towards final state, and by taking care of the condition itself. So for each state we'll have to check for each input, and while reaching to the final state, by considering that input, we'll have to check the condition also, and that is what we did right now. Okay, so let me clear this diagram, and now we have the fair one right now. Okay, so let me fair it so that we have the clear visualization of that one. Okay, so we have this Q0, and what we did for this 0 and for this 1, that is initial level for minimum length of string. This is Q0 is the initial state, Q1 is the intermediate state, and this is QF, and which is what, QF, and this is what, this is the final state. Okay, and what we did in this state, we already consider this case for 1 input. Okay, so in this state we are done with this 2 inputs, that is 0 and 1. Now in Q1 again we'll have to take care of what? 1 is done here, so we'll have to consider 0. So again we have 3 options. For 0 I can move here itself, I can go here itself, and I can take this one also for 0. Okay, for 0. Now 1 will be going to be accepted, and others will be discarded. Now see, if I'll take this 0 sorry, if I'll take this 0, again what will happen? We'll start from initial state. So for 0 I will be in Q1, and if I'll take this 0, then what will happen? We'll reach to QF. So for a single 0 and double 0. So what I am doing, I am starting from the initial state, and I will reach to final state, considering that input which I am considering right now. I am considering this one. Okay, so double 0. So what is the condition? The string should be contained 0, 1 at last. So we have 0, 0 at last, and we are not going to consider this one. So it will be discarded. We are left with only 2 options, self loop and this one. I am going to consider this one. Okay, let's try to understand. So for 0, I'll reach to Q1. Again by 0, I will reach here. After taking 1, see. First 0, I will reach to Q0 to Q1. After taking again a 0, I will reach to Q1 to Q0. Why I am taking this one? Because I have inserted this one. I want to consider this one, this input. So 0 is, again we are in Q0, we have 1. I have written this 1. Again 0. So I reach to Q1. Again I have only 1. This is, right now we are not considering this one. Again we have 1. So we are left, we are, at last what we have? This 0, 1. Yes or no? And we have this 0. So might be you think of this, that this is true. But see one thing. Again we have this 0, 1. Again we have a 0 in here. Okay. So it means what? 0, 0, 1. It should be accepted or not accepted by the machine? Yes. See. If I'll do, we'll see this string. We'll move from, start from Q0 to Q1 for 0. Here again a 0. So from Q1 to Q0 and 1. So we are in Q1. So this, after reading this string, we'll have to reach to QF, but we are not ended in the final state. We are ended in somewhere that is in Q0, that is in initial state. So it will be not accepted by the machine, but it should be accepted. See the condition. So whatever I am thinking. So remember one thing. Whenever you give a branch to the back side, you'll have to take care of the loop also, loop elements also. So when you are forwarding when we are forwarding towards the final states, so need not to consider that loop itself, but whenever you take a backward approach, okay, so consider this loop also and try to get the string. And this is the approach, this is the two approach, that's all. So this will be not accepted. Why not accepted? I told you. And last but not least, we are left with this option, and this will be accepted. That's all. Now in QF, again, after reaching the final state, it doesn't matter with that we are not going to, we'll have to not see for 0, 1. We'll have to again consider this 0, 1 here itself. Okay, so what will the input? Again, we have three options. For 0, I can reach to QF itself, so I can take a loop, self loop. I can go backward to Q1, I can go backward to Q0 itself. So what will happen? So by considering all the conditions, I will take 0 here. See what will happen? From starting from Q0, after taking 0 to Q1, after taking 1 to QF, again I am taking 0, Q1, and again I am 1, taking 1. Okay, see, 0, again 1, again 0, taking care of this loop also, again we have this 0, and again we have this 1. See, at last what we have? 0, 1, and it should be accepted. If I left with this 0, 1, because we have taken backside, so this 0, 1, 0 should not be accepted, and 0, 1 and 0, it will be not accepted. That's good. So we are going to take care of this one, this line itself. Again we have three possibilities, but I have choose the right one directly. So for 1 where we can go, so see 0, 1 and 1 we can take the self loop. So 0, 1, 1 will be accepted, so I am not going to take that self loop. The self loop condition will be not validated by that one. Again I will not going to take that Q1 itself, otherwise 0, 1, 1, 1 will be accepted. So I am left with only one option, that is what we are going to take this one right now. For this is. So this is how we are going to make a DFA. So we want to take a clear look of this one. So let's see. So this is how we have made logically. So this is for 0 and 1. For 1 we'll have self loop, 0 again we'll have self loop. For 0 we have again here, branch is here, and for 1 we have Q0. Okay. And now let's see the 5 tuples related to this one. The 5 tuples which is required to define a DFA. We have this Q. Q is a what? Set of states. It is clearly visible here. So we have Q0, Q1 and Q2. Good. And input is what? Input alphabet is 0, 1. That is for input table. See, sigma is there, 0, 1. Again what we have? This is initial state. What we have? Initial state. This is starting state. We can see by using this one. We have the final state, only a single final state. Final state can be more than one. So here we have only a single final state, and this is a transition function delta del. So by making a table we can see the transition. See what is the transition? Del after reading this is initial state by seeing this arrow, and this is Q2, and this is final state Q2, and what we can see, this is a transition function between what? State and input alphabet. Okay, so this is what, see, if I'll write del Q0 after reading 0 input, Q0 after reading this 0 input will reach to Q1. We will reach to Q1. See Q1. So in Q0 after reading this 0 we will reach to Q1. This is how we are going to make this table itself. And this is how transition function is there. So see what is happening there. This Q always mapped with this input. So this Q state will be cross product with this, and what we are going to get the result? We are going to get the result from the state itself. So this Q is from, this Q is from state, this input is from where, and we'll have to do cross multiplication. That is how we have seen in definition. Okay, and it is going to give you what? Mapping to the Q itself. See, this is what Q1 is there. This is what we have. So this is the definition which we have seen. And let me tell you one thing more. So this is what string is ending with 0 1. What will be the case if it is a not ending with? What will happen if I'll write not ending with? Not ending with. So for that, what will be the approach? First of all, we'll have to make this diagram which is ending with 0 1, and for that not ending with 0 1, what we'll have to do? We'll have to make this final state as a normal state and the non-final state as a final state. It means I'll have to make this final state, this is as a final state, and I will make it a normal state. This will be not a final state because it should not end with 0 1. So firstly it will accept all the input that is going to be ended with this 0 1, and now it has become a normal state, and this is initial state and final state as well, this one and this one also. So now it is having two final states. So this thing will be going to be changed. Okay, so for final state what we have two states here, that is Q0 and what? Q1, not Q2 here. Okay, so if anyone talks about that not ending with, first of all go for ending with and just convert the states, final state to normal state and non-final states including initial state to a final state. That's all. Hope this concept will be clearer to you. And last but not the least, thanks for watching my video, and in my next lecture we are going to see more problem on this DFA. Okay, thanks.